Alright, right triangle trigonometry. We definitely need to talk about special right triangles, 45, 45, 90, and 30, 60, 90. The good thing about these triangles is if you know one of the sides for either of these two types of triangles, you could figure out what the other two sides are just by knowing these ratios here. So let's look at some examples. 45, 45, 90. So these are pretty easy because this is an isosceles triangle, which means that the two legs have to be the same, which is why these are the same here. This is an S for side. A lot of people use x root 2. The only problem is when you're dealing with a particular problem on an exam and they got x's in there, everything gets mixed up. So I like to keep everything separate. It's called an S. Okay. So in other words, easy example here, what if this side was 5, right? Well, all they're saying is the side opposite, the 45 is 5. Maybe I should choose something else, it doesn't look like an S. Let's call it 3. Okay, so what they're saying is if this side is 3, then this side has to be 3, right? And if this side is 3, this side has to be side times root 2, or 3 times root 2, since we know what S is. Okay, what if they gave you, what if they told you this side right here, the one across from the 90, was, I don't know, let's say 13. So they said that this side here was 13. Okay, well, I got to figure out what these two sides are. I know they're going to be the same, but how do you do that? Well, that's when you look at your what you know here. So basically they're saying 13 is the same exact thing as S root 2. So if those two are the same, all I got to do is set up an equation. So S root 2 is the same thing as 13. Now I can solve for my side. Once I know what the value of S is, I know what the value of that side is, and that side is, right? Because that's what S is. Alright, so I get S is equal to 13 over root 2. Remember, we always rationalize, multiply top and bottom by root 2. So we get that S is equal to 13 root 2 all over 2. So essentially, every time, so I know that this side right here is going to be 13 root 2 all over 2, and this is going to be 13 root 2 all over 2. Not too bad, right? Okay, same kind of principle here. If you know any of these three sides here, you could figure out the other two. Okay, it's as simple as that. So obviously let's look at an easy one here. If the side across from the 30 was, say, 5, now let's do another one. Let's do 9. So the side across from the 30 is 9. The side across from the 60, which is this side, is going to be 9 root 3. So this would be a 9 root 3. And the side across from the 90 is going to be 2 times that S value. Well, I know S is 9. So 2 times 9, or double that side, is going to be 18. Alright, and let's look at one more. Be a little more tricky. What if they gave us a side across from the 60 was, say, let's go with 7. Okay. So obviously if it was 7 root 3, I know right now S root 3 is equal to 7 root 3, so S must be 7, which would mean the side across from the 30 is 7, and this would be 14 here. But that's too easy. Let's see, what if it was just a plain old 7? Okay, well, I know that that 7 is basically the same thing as S root 3, so I can set up an equation then. So I get 7 is equal to S root 3, divide both sides by root 3, and rationalize, we get 7 root 3 all over 3 is equal to s. So now I know what this is right here. So the side across from the 30 is just going to be 7 root 3 over 3. And the side across from the 90, well, how do I figure out that? Well, that is 2 times the value of s. Well, if s is this, what is 2 times this? Well, 2 times 7 is 14, so it's going to be 14 root 3 all over 3. Alright, enough of that. Let's look at the competition from a few weeks ago. So find the value of x. Okay, so there's x over there, but they didn't give me any sides of this triangle. So hopefully I can figure out what the side is right here, and then I can be able to figure this out, because it's a 30-60 90 and a 45-45 90. So all I need is one side, and I can figure out the rest of the triangle. So like this one here, this one side they did give us was across from the 42, or across from the 60 rather, was 42. So across from the 60, we call it s root 3. So s root 3 is equal to 42. Solve for s, because once we know what s is, we know the side across from the 30, which is what we want. We want that one right there. So divide by root 3, rationalize, and you get this value of s, the side across from the 30, is 14 root 3. Okay, so I know this is 14 root 3. Now we're dealing with the 45, 45, 90, so I'm just looking right here right now. Okay, which side do I know? I know the side that is across from 45. Okay, so I know the value of s is 14 root 3, right? But we need to find s root 2, because that's the side that's across from the 90. So, s root 2, take the value of s, and just plug it in there, right? 14 root 3 times root 2. We're multiplying radicals. That is when we combine those underneath the radical. 3 times 2 is 6. That stays like that because 6 has no perfect squares as factors, so we are done. X is 14 root 6. Okay, so let's start going through these. In a right triangle, RST, so RST, okay, right angle T, it says angle R is 7 over 25, so cosine of R. So there's R. Remember, cosine is adjacent over hypotenuse, so that's going to be 7 over 25. Okay. Okay. And it says if triangle XYZ is similar to RST, what can we say? What must be equal to cotangent of Y? Okay. So they said these triangles are similar, so I set up another triangle here. So I know that the corresponding sides are going to be proportional. Okay. So the blue one's proportional, the greens are, and so are the reds. So if that's the case, let's see what we got going on here. Cotangent of y. So what is that? Cotangent of y. Well, what is tangent of y? Remember SOHCAHTOA. Tangent is opposite over adjacent, so cotangent is the inverse, which is going to be adjacent over opposite. Adjacent is zy, and opposite is xz. So since I got all color coordinated here, I'm going to find the other values of these other ones and see which ones have a red over blue. And that'll be it. So cosecant of r, well, that's the inverse of sine, and sine is opposite over hypotenuse. So sine of r is over h, so we want cosecant, which is going to be h over o, so hypotenuse over opposite. Okay, so right away I see this has got a green one in here, so that can't be the answer. Basically what we're doing, we're looking for, either in this triangle or this triangle, the bottom side, the shorter leg to the longer leg is essentially what we're looking for. Short leg to a long leg. If any of these have that ratio, then that's a correct answer. Tangent of x. Tangent is opposite over adjacent. So opposite side is red, adjacent is blue, and that's what we want, right? We want small side or small leg over long leg. So that's a good one. I'm not going to go through all these, but let's look at another one. It doesn't work out. Sine of S. So I put my finger on S, and I say sine is what? Opposite over hypotenuse. So opposite over hypotenuse. Is that what we're looking for? No. That's no good. How about tangent of R? Tangent of R. Well, tangent is opposite over adjacent. So opposite is right here. Adjacent is right here. So that's what we want. Short leg to long leg. Alright, you can do it for the other ones to see which ones do and do not work. But that is a general idea. So then these three answers here would be correct. Alright, one more. In the diagram, simplified form, okay, blah blah blah. Basically we got to write it x like this, okay? And then always read the question. Once you get in that form, we got to multiply all these numbers together. So where do we start here? So we got to find x over here. So I was looking at this and I said, well, I don't know what this is over here, but I could probably figure out this somehow, and I could probably figure out this somehow. So if I can figure out those two, I can figure out the whole length from there to there. And if I knew the whole length from there to there, I have a side of a 45, 45, 90 triangle, and I could figure out that other side. So let's first work on finding this side, and then we'll work on finding this side, and then we'll go from there. Okay, so looking at this is a 30, 60, 90 triangle. We know that because all the angles have to add up to 180. If that's a 60 and that's a 90, that has to be 30. The side across from the 60 is 24. Okay, so remember our special right triangles. That side across from the 60 is associated with side times root 3, and we know it's 24. So now I set up an equation, solve for s. S is just going to be 8 root 3. So that's why the side across from the 30 is s, or this side right here, which is 8 root 3. Alright, and this triangle down here, we got a right triangle, and I know two of the sides. If I know two sides of a right triangle, I can find a third one by doing the Pythagorean theorem. So I did that. Leg squared plus leg squared equals hypotenuse squared. Solve for t. T is 10. Okay, so now I know the distance from here all the way to the bottom is going to be this 8 root 3 plus the 10, or 10 plus 8 root 3. Alright. Now it's a 45, 45, 90 triangle, so it's going to be x, x, x root 2. The side we are interested in is this one right here, but I need to use this one in order to figure it out. So what is the side called across from the 90? Well, that's x root 2 or s root 2, whatever you want to call it. I used x here because they already used x for one of the sides across from the 45. So we would say that this side over here is x root 2, but it is also 10 plus 8 root 3. So now I've got my equation with a single variable. I can solve for x, because once I know what x is, I'm done, right? So divide both sides by root 2 to get x by itself. We rationalize, multiply top and bottom by root 2. Distribute that root 2 to the 10 and the 8 root 3. Gets this. Root 2 times root 2 is 4. Or is 2 rather. And then 10 divided by 2 is 5. 8 divided by 2 is 4. So now we got it in that that form right here. So we got A, B, C, and D, and they said multiply them all together. 5 times 2 times 4 times 6 is going to be 240. That is all. Godspeed.